Okay, welcome back. We left off on classes versus objects. So again, chapter 6 has an awful lot of philosophy in it, so you have to be understanding what's going on. So primitive versus object. So primitive data types like integer, right? And then object ones like, that are part of a class, right? Like string or something else, or employee or whatever else that we make. So there's a lot of differences between the two, and typically, if with it, you have to use a new operator to create a brand new thing, and remember how the class name typically appears twice. Now it doesn't do it for string because string is different, but typically that's what you would end up doing. Okay, so the next one is class names. So this is one of those, what are the rules? Which of the following are true of the rules and best practices for naming classes? So yeah, that one I think is pretty simple. The next one talks about an access modifier, and in particular the private access modifier. You need to tell me what the heck is this thing is for. And for God's sake, I'm not asking for a definition. Like, oh, private makes things not visible. No. I'm asking why. So what's the purpose here? What is the fundamental purpose of making something private? Is it to keep secrets? What's it for? If you understand what's it for, a philosophical question, what's it for? I think you'd be in good shape. The next one, of course, is the very high, very much philosophical. Like, why are we doing this? What is the point of object-oriented programming? I mean, there's got to be a reason. Otherwise, we wouldn't go through all this junk. So what are the rules? Not rules. What are the reasons? I gave you a whole list of things. So yeah, if I'm asking you to describe the purposes, why are we doing this? You should be telling, well, it's because of this, and this, right? You should be able to answer these things. It's all available stuff that you can find out. A very philosophical kind of question. Constructors. What are the rules for building a constructor? Now, one of the rules for a constructor is the oddest one I've ever seen in programming, and that is that one of the rules is you don't have a return type. Isn't that strange? It's a method without a return type. That's very odd, and so it's very difficult to spot that as an error. Like if you were just looking at an application, right, and you're used to seeing public and private on every single method, your eyeballs are going to just flash through that and say, yep, everything is just fine, until you hit compile, and it's going to come back and say, hey man, what the heck is this? It's just too dang hard to spot because you're not used to having it without a return type. Okay, the next one is instantiation. That is a cool word, instantiation. So it's going to be one of those things about, when you use the new operator, typically, like employee imp1 is equal to new employee imp1, and then you employee, and then you put some stuff out there. So tell me again, why does the class name appear twice in that line of code? Okay? Got it? Okay, good. Parameterized constructors. So I'm taking, it's a constructor, and I'm taking like the first name and the age off of the command line. Off of as parameters. Okay? But I need to validate them. I want to make sure that age is not 400 or minus 40. So how do you do that? Do you just put the input validation stuff smack dab in the middle of the constructor? Is that how you do it? Or perhaps there's some other way of doing it that won't have you duplicating any code. So every single example that we did in class uses this technique. Now I will tell you that absolutely none of the examples in the book use this technique. So this is a big fat no in here where it talks about parameterized constructor. Absolutely no, because it's not mentioned at all in the book. So yeah, you're going to need to be paying attention. And then what makes up a method signature? Remember, the signature is the way that the machine can tell two different ones. If I had calc pay and then another calc pay with the exact same name, that's perfectly illegal if The method signature is different. So what is in the method signature? What makes up a method signature? Or I could ask the other way, what thing does not get included in the method signature? Because that's a significant one. If you can remember what doesn't make up a signature, the ones that do make up the signature are actually pretty easy. So what makes up a method signature? Chapter 7 about arrays. Hip, hip, array. So arrays are, remember, they're zero based, right? So if I said I wanted 5 of these things, the last one's going to be a 4, right? Because 0, 1, 2, 3, 4. Good. Okay, got it. Bounds checking. Built into the array class is what happens if I step off the edge of the array. I say I wanted 5 of these things, 0 through 4, and I ask for element number 5. The machine's going to come back and say, dude, what the heck? It's going to throw an exception, an index out of bounds exception. So I'm going to give you an example and ask you, is this going to generate an exception or not? So it's kind of simple. The initialization list. So instead of just having an array and then have you add things individually, there is a way you can do it all in one line. I mean, there's not a lot of cases where that would work, but I could say, int square brackets, name, scores, and then put in a curly brace and then put in, 88, 94, 16, 12, and then close the curly brace, right? I can do that. So what are the rules for doing this, and what can I not put in there? If I choose to use the array initializer technique, what rule do I not use now? Okay? So before you had a rule how to pick the size of an array and do all the rest of that stuff. Now what do you have to do? So the next one is the enhanced for loop. So enhanced for loop is pretty doggone cool. I mean, he is super fast, but unfortunately he's got an awful lot of limitations. The things that make him fast also makes it so that it is not suitable in an awful lot of scenarios. So what are those scenarios? Where could I not use an enhanced for? That'd be a good question. A two-dimensional array. Okay, for the two-dimensional array, there's something that's kind of odd, and it's kind of unique to Java. Getting the length of the first axis is trivial, but getting the length of the second axis is not at all trivial. Can you remember how to do that? Okay. The array list. So the array list is actually pretty cool. So why wouldn't I use it everywhere? I mean, if the array list is so cool, it allows me to add insert things in the middle, delete things. I can change the size of it. I don't even have to know what size it is to begin with. All these really cool things. But why would I not want to use it? There's got to be a trade-off here. I mean, right? I mean, there's got to be a trade-off. What is that trade-off? Why is it I can't use it everywhere? That's a good question. A good philosophical question. And then I'm going to give you an example and say, does this look right to you? Is anything wrong? Is this going to throw an exception or not? That kind of stuff. And then the extra credit questions. So I'm going to tell you exactly what the extra credit questions say, okay? Because I really want you to kind of sort of do well, and I want everyone to be able to kind of do this thing. So it's going to say, write me a class called Kumquat that has an integer age as with getters and setters. Okay? And remember to do input validation. So I'm going to ask you to write me a class that's got an age field with getters and setters and input validation. Okay? The next one. Write me a function called sum that takes an array of doubles as an argument and returns the sum of the elements. Okay? So you should be able to do well. I'm telling you exactly what the questions are. Okay. Please do study for the exam. If you run across something in here that you're not that familiar with, fire me off an email saying, hey, I kind of halfway remember what you were talking about with error messages, but could you go over that one more time? That kind of stuff, that's perfectly okay. Okay, we've reached the end here. So please do study for the exam and do well. And I'll see you again in the next chapter.